We're going to use the rational root theorem to find all of the possible rational roots or x-intercepts for this polynomial function. So the two things you need to pay attention to are what we call our p's and our q's. So your p is your constant value, so we're going to say p is equal to 16. And your q is your leading coefficient, so q is equal to 4. So once you find those two numbers, what you're going to do is you're going to write down all of the factors of those numbers, right? So any number that evenly divides into it. So for 16, right, 1, 2, 4, 8, and 16 are all factors of 16. And then 4 has factors of 1, 2, and 4. So then to find our possible rational roots, this is our little formula. So our PRRs are plus or minus, so the positive or the negative of any p value divided by any q value. So we're going to start making our lists. So now one thing to help out is to know how many answers you're going to have. So in my my p list, I have 1, 2, 3, 4, 5 answers. And in my Q list, I have 1, 2, 3 answers. So overall, I'm going to have 5 times 3, which is 15 PRRs. So what I'm going to do is I'm going to go ahead and make myself 15. Whoops, that was weird. I don't know what my Apple Pencil is doing here. 15 kind of little fraction setups. So, whoops. iPad is being super weird today. Let's try this again. So there's 1, 2, 3, 4, and let's see, I got 5. And then, let's see, there's 5, 10, and 15. So I have a spot to write each one of my PRRs. Okay, so I'm going to take each of my p values and put it over each of my q values. So I'm going to do my first p value here. So I'm right here with 1. So I'm going to do 1 divided by my first q value, which is also 1. And then I'm going to go back into my p list. I'm going to grab my first one again. So I'm going to do 1 over my second q value, so 2. And then 1 over 4. And then I'm done with my 1 in the p list, so I'm going to cross it off. And then we're just going to continue with that pattern. So then I'm going to divide my 2 values. So I know I'm going to have 3 of those fractions, so I'm going to put 3 of them in. I'm going to divide 2 by each of my q values. So 1, 2, and 4. I'm just going to keep going. So then I'm crossing off my 2. I'm done with that. And then I'm going to divide my 4. So I'm going to have 4 in 3 of my tops. And then I'm going to divide that by my q values. So 1, 2, and 4. Done with the 4. So now I'm going to divide my 8s. So I've got 8, 8, 8. And I'm going to divide that by my q values. 1, 2, and 4. And then the last number I have to do is the 16. So I have 16, 16, 16. See how I filled out all of my fractions? And then 1, 2, and 4. So now all I have left to do is simplify. So my first fraction, plus or minus 1 divided by 1, well 1 over 1 is just 1. So I'm going to get plus and minus 1, so I'm done with this one. And then 1 over 2 is going to be plus or minus 1/2. And then 1 over 4 is just 1/4. So as I simplify, I'm just crossing them out, so I know I've already dealt with that. So then I get to 2 over 1. Well, 2 divided by 1 is 2. And then I get to 2 over 2. Well, 2 over 2 is equal to 1, and I've already used that 1. So I can cancel this one out because it's a duplicate. And then 2 over 4, that reduces to 1 over 2, 1/2, which I already have, so I'm going to cross that out. My next one is 4 over 1, and I don't have that number yet, so plus or minus 4. Then I get 4 over 2 is 2, which I've used already, so I'm going to cross that out. And 4 over 4 is 1, and I've used that before, so I'm going to cross that out. Then 8 over 1 is going to give me 8. Done with that one. I guess these should kind of just be check marks because we've done them. We'll make them check marks. And then let's see, 8 over 2, that's equal to 4. That's already on my list, so I'm going to cross off my duplicate. 8 over 4 is equal to 2, already on my list, cross off the duplicate. Then 16 over 1, we get plus or minus 16. So we're all done with that one. Then 16 over 2 is 8, already on my list. And 16 over 4 is 4, which is already on my list. So when we're done, our final list of PRRs is just this number. So these are all of the possible whole number or fraction x-intercepts for this equation. So we can see the whole thing.